What comes to your mind when you hear the word cancer? Probably you're thinking about a constellation, a zodiac sign, or a disease. But what do these three things have in common? The word cancer comes from the Greek karkinos, that means crab. The disease received its name thanks to the observations of Hippocrates in the ancient Greece of some big tumors with veins that resemble the legs of the animal. But why are tumors formed in the first place? All the cells of your body grow, acquire a specific function, divide, and eventually they die. The cells have a lot of proteins that regulate these processes, but what happens when some of these proteins are mutated? Some mutations can cause your cells to grow and divide without control, forming tumors. One of the most lethal types of cancer is colorectal cancer, the third most common type of cancer worldwide and the second leading cause of cancer deaths. KRAS is a very important protein in colorectal cancer because it's mutated in 45% of the cases. But all the efforts to design drugs that specifically target KRAS have been mainly unsuccessful. Nevertheless, KRAS activity relies on small changes in the protein, such as phosphorylation. Phosphorylation adds only 5 atoms into the protein, but these 5 atoms can change the behavior of the cells completely. We have studied in the laboratory how KRAS phosphorylation may affect cancer properties. We compare colorectal cancer cells that can phosphorylate KRAS with colorectal cancer cells that have a mutation and cannot phosphorylate KRAS. And we analyze the secretome composition, the proteins that are secreted, released into the media. And we observe that in cells that can phosphorylate KRAS, there's more secretion of proteins related with cell invasion and metastasis. Among these proteins, we have cathepsin B, which degrades the extracellular matrix and allows the cells to move. This is the reason why we decided to inject these cells into the spleen of mice to see if there was metastasis in the liver. And we observed that in phosphorylatable cancer cells, there's a lot more metastasis than in non-phosphorylatable ones. The next step would be design drugs that inhibit KRAS phosphorylation, because this result shows that KRAS phosphorylation directly regulates metastasis. Can you imagine the powerful that is this statement? Only 5 atoms to control cancer. Only removing 5 atoms to kill this fatal crab. Thank you very much for your attention.